Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking at Geometry Part B. This is Lesson 2, and we're looking at how to prove triangles are similar. So again, this is information covered in the lesson content. So please review the lesson content as you watch this video so you can get some more explanations. So let's take a look at how we prove that triangles are similar. So our previous proofs, we were looking at how to prove things were congruent. And now we're looking at similarities. So here's our first method for proving that triangles are similar. It's called the angle-angle similarity postulate. And you notice we use this notation right here, AA, with a similar symbol right here to abbreviate. So let's take a look at what it says. It says if two angles of one triangle are congruent to two angles of another, then the triangles are similar. So if you take a look at what this means, you see right here, we've got these congruent to each other and these angles congruent to each other. So if those two angles are congruent, then we can show that those triangles are similar. So let's take a look at how we apply this to a problem. So are these triangles similar? Well, I can see that I have one angle that is congruent. I already have that, but I don't have another. So I might have to do some work here. So we're going to have to give an explanation of why these aren't congruent, or similar, excuse me, not congruent. And then we're going to make a similarity statement with a reason. So first of all, what we can do here is we're going to use some rules that we learned about triangles, that the sum of all three angles of a triangle equals 180, to figure out what angle A is. So if we subtract 180, if we subtract 60 plus 40 from 180, I should say, what we'll get that this angle A right here, is 80 degrees. Well, look at that. I've got two angles that are congruent. I've got angle A is congruent to angle N. I've got angle B is congruent to angle M. So I've got A is congruent to N. I've got B is congruent to M. So guess what? I've got two angles that are congruent, so I have similar triangles. So I can say that ABC is similar to NML. And the reason is by the angle-angle similarity postulate. So that's how we're going to use this to problem solve. Let's look at a proof that involves the angle-angle similarity postulate. So here is our picture. And what are we told? Looks like we're told that some sides are parallel to each other. So we've got DE is parallel to CB. And we want to prove that triangle ADE, which is the small triangle, is similar to ACB. So now again, we always want to kind of think these things out before we start writing. Because I have parallel lines, I have some corresponding angles. And corresponding angles are congruent. So this angle right here, angle ADE, will be congruent to ACB because of corresponding angles. I've got the same situation over here. AED will be congruent to angle ABC. So I'm going to use that to help me prove by angle-angles. Let's take a look at our statements and our reasons. So our first is that DE is parallel to CB. That's given. So now we're going to do those corresponding angles. Angle ADE, which is that first angle I talked about, is congruent to ACB. I could have just said angle C, but keep it consistent. I'm going to use the three letters, and that's by corresponding angles theorem. Same thing on the other side. AED is congruent to ABC, and that's the same reason, corresponding angles. So I've got two angles that are congruent, so I got the triangles are similar. ADE is similar to ACB by the angle-angle similarity postulate. So what's our next theorem? We got side angle side similarity. So that's SAS with the similarity symbol. You notice these are a lot like the congruence theorems and postulates, except we have similarity now. So we're going to use some of the same things to show similarity. So here is our theorem. It says if an angle of one triangle is congruent to an angle of the second, and the sides that include the two angles are proportional, then the triangles are similar. So what does all that mean? So here is our picture. We've got that A is congruent to D, so that's our congruent angle. So the sides would be that AC over DF would have to be the same as AB over DE. So if A is congruent to D, which we have, and AB over DE, which I said it the other way, AB over DE is the same as AC over DF, then we can say that the triangles are similar. Let's look at how we apply this. So here's an example. So here is our picture. We've got that. We've got two triangles that are side by side, sharing a vertex right here at W. We've got some numbers here. So let's see how we can show that these are similar. We need to give an explanation and we need to write a similarity statement. So let's start off by looking at the proportions. So let's look at UW over YW. Well, that's 10 over 12, which is 5/6. Reduces to 5/6 because you can divide by 2. And let's look at VW over XW. That's 15 over 18. Divide both of these by 3 and we get 5/6. Well, look at this. Both of these are the same. So that means that those two sides are proportional. UW over YW is the same as VW over XW. So that's our sides. Now, where's our angle here? Well, our angle will be this vertical angle right here. UWV and XWY. I think I'm going to use YWX to make it consistent with the lettering. So VWU. So VWU is congruent to XWY. And that's by vertical angles are congruent, the vertical angles theorem. So now we have the angle, we have the sides are proportional. So now we can say that the triangles are similar by the side angle side theorem. And then let's look at a proof that involves this. These proofs tend to be kind of short. So let's look at what we're given. So here's our picture. What are we told? We're just told that AD, which is this segment right here, over AC, so this whole segment, is equal to AE over AB. So we're told that those two sides are proportional. And then we're going to prove that ADE is similar to ACB. So how are we going to do this? Well, we've got the sides are proportional. And look at this. We've got this angle that they share. They share the same angle. That's reflexive property. So we've got enough right there with just 3 little statements to show that this is a set of similar triangles. Here's our statements and our reasons. First statement is that the given AD over AC equals AE over AB. That's given. So that's our proportional sides. We know that DAE, which is this triangle angle, is congruent to CAB. And you notice I use the letters from the triangles. I could have just said angle A is congruent to angle A. Bottom line, that's the reflexive property of congruence. So I have my sides are proportional and the angle in between those two sides is congruent. So that's enough to tell me that the triangles are similar by side angle side theorem. And finally, we have the side similarity theorem. So what does it say? It's real simple. If the corresponding sides of two triangles are proportional, then the triangles are similar. So that means that all 3 sides have to be proportional to each other, so the same ratio. So here is the picture. And basically what we're just saying is that if all 3 sides are proportional, so AD over DE, AC over DF, and BC over EF, if those all equal the same value, then we have similar triangles. So we're just going to show a problem for this one. This one's a little more difficult to show up in a proof without a lot of, doing some other things. So we're just going to stick to a problem solving on this one. So are these triangles similar? We're going to give an explanation and then we're going to make a similarity statement. So what are we going to do here? So all we're given is information about the sides. So that means we're going to have to set up the ratios. So we're going to set up all 3 ratios. So AB over RQ. And these, you kind of notice which sides go together. So make sure you just notice which sides go together. Then we got AC over RP. So that's the long sides, AC over RP. And then finally, BC over QP. So if all three of those turn out to equal the same, then we have similar triangles. So let's take a look. AB over RQ. That's 15 over 10. Divide both of those by 5 and we'll get 3 over 2. Let's take a look at the next one. AC over RP. AC is 39, RP is 26. Divide both of those by 13, and guess what? We get 3 over 2 again. And then finally, BC over QP. That's 36 over 24. Divide both of those by 12. 36 divided by 12 is 3. 24 divided by 2 is 2. 24 divided by 12 is 2. So all three of these turn out to be the same. So since these three all are equal, and guess what? We've got similar triangles. ABC is similar to RQP. Make sure you label those in the right order. So A goes with R, B goes with Q, C goes with P. And what's the reason? Side, 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 similarity theorem. So I hope this helps you with proving that triangles are similar. If you still struggle with this content as you're working on the assignment, please let us know in a teacher message or make an appointment for a help session.